vacuum leak. That's not true. The upper intake doesn't have any coolant going through it. Okay? So remember that. Now this is 7, engine performance 1 test 7. Technician A says the pulley on a centrifugal supercharger is larger than the crankshaft.
No.
No. Technician B said, yeah, centrifugal superchargers are driven by exhaust gas. Neither one of those guys are right. Supercharger is driven by a belt. Takes a little power, makes a lot of power. Okay, which of the following is correct? The bypass valve opens in reverse gear. The bypass valve is closed during acceleration. Most manufacturer equipped superchargers have a bypass valve to control boost. All of these are correct. Now, why would the bypass valve open in reverse gear?
Don't you go in reverse too fast?
Well, think about what's going on in reverse. Back in the, heck, I don't know, it may have been 20 years ago, there was a bunch of these Audi 5000s that people were saying there was something wrong with the car because they would put it in reverse and the car would run away with them and crash into something. And this happened quite a bit. And of course there was a lot of publicity about it, and it turned out that an independent insurance investigation was done that determined that every single one of those incidents was driver error. The car was not at fault in any way. And what they would do is they would back that car, when they went to back the car up, they'd have their foot on the gas instead of the brake. They'd put that car in reverse. What happens when you put it in reverse? On a cold engine, you got fast idle, right? They'd put that car in reverse, and the car would surge backwards. And when it surged backwards, it would throw the driver's foot against the gas. And the more the car accelerated, the harder it was to get off the gas. And they just couldn't stop. They couldn't pull their foot off the gas or think quick enough to do it. And it just kept going faster and faster and faster, pushing them against the gas. Your foot's on the gas pedal, and that's actually, it's like a snowball effect.
How fast will one generally get up to in reverse?
In reverse, it can go 80 miles an hour because it's like equal to second gear. You know what I mean? But if you're going across a parking lot, you're going to run into somewhere. You're going to go through the mall or something, you know. And that's the kind of thing. And so what did they do about that? What do you think they did to fix that? It became a federal requirement on every car with an automatic transmission that you had to put your foot on the brake to put it in gear. You can't take a car that's, after that regulation went in place. We had to go back and retrofit a bunch of Jeep Cherokees with shift interlock cables that had a solenoid in them that was tied into the brake pedal. So that when you had to take the console out and all kinds of stuff, it's a pain. But we'd put that thing in there whenever you had to mash the brake to take it out apart.
Recall work.
That recall was because the federal government wanted those Jeeps fixed, and I'm sure some of the other auto manufacturers had recalls like that too. But that was an important thing. So if you've got a supercharger and this thing takes off a little more strong, when you're going backwards, it's liable to throw your foot against the gas. You see? Now here's another thing. How many of you have ever put your foot on the gas? Well, have you ever seen this? Put your foot on the gas and the throttle plate was stuck in the bore. And to start with, it feels like you're standing on a brick and it won't move, and all of a sudden it pops loose. Oh, you ever heard that? You ever felt that? Sometimes that happens, like you even taking off forward, it would do that. And if you're in a situation where your throttle plate's stuck in the bore, even on I think your car's got, and my car, my pickup truck, have got electronic throttle plate. All right. What happens on those, that throttle plate still sticks in the bore, but when you're giving it gas, you're moving your foot, and the car ain't moving, and it applies a little more current to that thing, and when that throttle plate pops open, it takes off. And so, but if you're backing up, I knew of this one woman that I read about one time, that she was driving her vehicle, and nobody knew why this happened, but I think I do. She put her vehicle in reverse, and whenever she went to take off, it got away from her, and it went all the way across the road into a pond, and she drowned. And everybody was mystified as to why she backed her vehicle across the road and into the pond instead of doing what she normally did every morning. And what happened was, I bet you, what I would submit, she got it, she put her foot on the brake, she put it in reverse, she put her foot on the gas, and it wouldn't, you know, apply, and you just naturally apply a little more, and when it did pop loose, it took off, and that same thing happened where it throws you against the gas pedal, as you couldn't get off the gas pedal. The next thing you know, she's in the pond. You see it in the car sunk, and, you know, and here she was, you know, she couldn't get out of it. But it was something that, you know, you couldn't really blame it on anybody necessarily, because it was just it was a perfect storm, like a stupid lug nut thing that happened. You know, everything comes together just right, and there's a disaster, and you're trying to figure out how can we avoid this in the future. But sooner or later, you'll hear somebody talking about when I stand on my throttle, it sticks, and when it pops loose, there's always the throttle plate sticking in that bore because of gummy black stuff that gathers up in there. Technician A says superchargers are driven by the engine crankshaft. Technician B says superchargers use synthetic oil inside the unit. Both those guys are right. There's a special plug you're supposed to screw out of there to check that oil every 30,000 miles on the ones with a supercharger on them that I know about.
Oh, it's 2.
No, 2 was basically all of the above. 4, Technician A says turbochargers send high pressure exhaust gas into the combustion chamber. Do they or don't they? Okay. Actually, it's not going to happen that way. What we got here, that is a crazy sporty question. Technician B says turbocharger use a belt driven by the crankshaft. That's wrong too. Neither technician is right. The turbochargers don't send high pressure exhaust into the combustion chamber. The exhaust that's coming out of the engine spins the wheel, you know, spins the impeller, and the turbine that's in the intake, since it's joined with a shaft to that impeller, actually is kind of like a fan that pulls air into the combustion chamber about through the intake. So it doesn't put exhaust gas in there. The EGR is what does that. The following statements, and it doesn't put it in there in high pressure either, by the way. The following statements are correct except A, turbocharger bearings are usually lubricated with engine oil. That's true. B, the turbocharger drains power from the engine. It doesn't. The turbocharger doesn't take any power at all away from the engine you know, in and of itself. How many internal wheels does a typical turbocharger have? It has 2, but they're tied together on the same shaft. Got it? You understand what I'm saying? Daniel, you understand about a turbocharger, how it, you know, you got 2 wheels, one's in the exhaust, one's in the intake. When this one spins, that one pumps air. I mean, if you just got 2 fans that are hooked together and you're driving one, the other one's going to pull air, right? It's like 2 fans. Imagine having 2 fans. If I took 2 of these fans like we use out in the shop, and I took the blades and I mounted them on a jack shaft, and I actually put a fan blade on either side of that shaft. All right, now I'm going to get me a big old air hose like I got from the air blower right here, and I'm going to blow it so that I'm spinning this fan on one side. The other fan is hooked to that same shaft, and it's going to spin too. So as I'm spinning this one, that other one's going to move some air in it. Okay, so where does the spinning power come from that spins the turbocharger? What spins the turbocharger? Exhaust gas. And exhaust gas is going through there anyway. See? And so as it just makes it feeds itself more or less. It's pretty good. Okay, Technician A says the turbocharger, turbine, and compressor wheels are on the same rotating shaft. He's right. That's what I've been talking about all this time. Technician B says it's a good idea to change the oil in a turbocharged engine less frequently than in a natural aspirated engine. Less frequently? More frequently would be better. Technician A is right about that one. Which of the following is essential to long turbocharger life? Keep the dirt particles and contamination out of the intake and exhaust housing. Duh. Flush the turbocharger unit when the engine's overhauled. That's a good idea. And maintain a clean supply of engine oil. You know how fast the turbocharger turns? That's all of those are correct. By the way, it's all right. All
faster than the engine.
100,000 RPM is what a turbocharger spins usually. 100. I mean, that's a sort of a blanket figure, but they spin really, really fast. All of these statements describe oil coking, except when the engine is set down, the turbo has less resistance and will continue to spin without proper lubrication. B, coking can be reduced by using engine oil to cool the turbocharger. And C, this happens when the camshaft is starved for oil. Oil flow to the turbocharger stops when the engine stops. So that's actually C is the right answer for that one. Finally, number 10, atmospheric pressure at sea level, 14.7 psi, that's per square inch, equals what?
A?
1 bar.
I knew it was that or one.
1 bar. Now you're going to see that a bar is the metric way of measuring pressure. So if you look at a fuel pressure gauge that's, and you even hear the people on hurricanes talk about millibars, you know how many millibars of pressure there are? They're breaking up a bar into thousands. See that? I mean, so if you take a bar is equal to the pressure at sea level. So we're used to saying 14.5 pound or 14.7 per square inch at sea level, but that's equal to 1 bar. So on a gauge, on a pressure gauge, for a fuel pressure gauge, if it's the Japanese or whatever where they're using metric, it will actually have X number of bars instead of, you know, pounds or whatever. That's how that works. Of course, they've also got kilopascals and other ways they do this. But anyway.
Nobody uses kilopascals hardly though.